And Eric is coming to us from Switzerland.
Thank you. Welcome all of you. I will present you AQUA4D. So first of all, the context. You all know about the worldwide major challenge with water scarcity and food protection. That means we are facing very complicated equation to feed a growing population using less resources, and we have to make it with less impact on nature. To reach this, we developed a customized hardware as a service for water smart agriculture, leading to water savings, energy savings, maximizing quality and yield potential of the crops, and maintaining green areas for communities, which is very important related to the global warming prevention. How we achieve this? We use resonance field water treatment for precision irrigation. And our solution is both a product and a service, as we are providing a technical support for installation, monitoring, irrigation management, and follow-up. And where we are very unique is the fact that we can leach excess salt into the soil while using less water in the process. And it's very unique because normally you need a lot of good water quality to make it. Our positioning is central within water management, regenerative agriculture, and sustainability, corresponding with the current ESG, SDGs, and climate change concerns. Regarding the case studies, we have thousands of installations in 5 continents, working with opinion leaders, major growers, and major worldwide partners. We are associated and supported by strong labels and partners, and we develop various articles and scientific studies from academic institutions worldwide. As I told you, we have plenty of installation with every kind of situation, for instance, with greenhouses, aeroponics, hydroponics, with landscape and green areas, and with open fields. We can work with small installation or bigger installation with skids, and we can easily supply with small solar panels as the energy consumption is very low. For instance, here the case of Agricola Famosa in Brazil, who is the first worldwide exporter of melons, facing very important salinity issues. We installed AQUA4D in more than 7,000 hectares, leading to very important reduction in greenhouse gas emission. The main parts relative to salinity issue as alternative to reverse osmosis, but also a significant part with water savings, meaning pump energy savings. On top of that, we reach an increase by 20% in production, and we have been able to reach 2 cycles per year in the same place thanks to the leaching effect regarding the salinity issues. We work with a strict monitoring. For instance, here you can see a map with an almond crops in California. We choose an AQUA4D treated side and we compare with a control plot. And then we put sensors on the soil to monitor the soil moisture, the ionic charge water. We make samples of soil analysis. We can use also subflow sensors, satellites and drones to be able to evaluate the development of the canopy and some health criteria like NDVI and visual inspections. That means we are working with a strong agronomical engineer teams on the field, and we have also a strong database to be able to show the level of improvement we can reach with soil moisture, production increase, water savings, energy savings, and so on. Because when we are talking about water savings, we are talking about energy, pump energy savings, using less chemical and less fertilizers in the process, using brackish water instead of drinking water, and leading to soil restoration and preservation. In the end, it's a lot of energy savings. To be sustainable is directly the DNA of a company. We developed what we call a shared value program for regenerative agriculture, and for instance, we fulfill 11 of these SDGs. So for more information, do not hesitate to visit our website and our YouTube channels, and thanks for your attention.
It's a major player on climate change, biodiversity loss, resource use. So we have deeply unsustainable food systems at the moment. And so companies, innovation, business models, food patterns that can push a fundamental shift in the food system are absolutely necessary. So I applaud that type of innovation definitely. My key question is, most of your pictures were from developing countries. What is the sort of level of capital investments that is needed, and to what extent is this appealing also to smaller farmers, because those are the most marginalized often in developing countries?
Yes, thank you. And it's a good question, because we are present, in fact, in many countries, and in some places, for instance, in California, we are talking with very important growers and farmland investors, and the financing is not such a big issue. But when we are talking with developing countries, it's exactly true that they cannot afford such an investment, and we need to talk with also financing means, and to talk with banks, development banks, to find some ways being able to these smallholders to invest in such technologies. So it's a global problem, and we need to have many actors all together, and regulation and governments and financing options to be able to reach these objectives with new technologies, and the regulation to be able to save water, to raise soil with salinity issues, and to make it sustainably in a sustainable way. So yes, the financing issue is very important in developing countries, and to be able to propose some renting, some leasing, some credit, or to get some subsidies, and the development banks and the World Bank can play an important role in this aspect.
Chris Hurst from the European Investment Bank.
But just to pick up on your last point, I mean, it is today the case that nearly 3/4 of all freshwater use is used for agriculture, and we have the population is growing, and so demand for food will be increasing, and so there'll be continued pressure on our water supplies. And we know over time, in some regions of the world, with climate change, water is going to get very scarce in some parts of the world. So there's a natural need for these kind of technologies that will emerge over time. But in the more shorter term, water is wasted, and water is wasted because it's cheap, and there's very limited regulation on extraction of water in many places. So in order for your technology to be adopted in the relatively short term, what sort of changes to regulation do you think you will really need in order so there's less incentive for farmers to over extract water and essentially waste it? We know they can do it. You use much less water than they do, and we see countries like Israel where there's a very reduced consumption of water by farmers because exactly of the regulations that exist on that.
It's a good question, and you're right. And if we take, for instance, the example of California, this year they face a very drastic drought, and the regulations are becoming more and more severe with the Groundwater Management Act, with some restriction regarding the water allocation. And at that moment, they need to destroy some of the crops because there are no more water available. That means with this kind of regulation, we can force people to use these new technologies to be more efficient in the water use efficiency, and this way we could be very efficient. And many organizations, NGO or public organizations, they are explaining that we need these new technologies, but to be able to save water or to deal with salinity issue is not enough. And without the regulation behind, sometimes they will just expand the crops lands, and we will solve nothing in the end. So altogether, and I know Bertrand Picard is really also involved with this aspect, we need policy regulations and new technologies, and to have the full picture to reach to important savings in the end, and to be able to face this food protection challenge and this water scarcity issue, being efficient but in a smart way.